Now let's try to understand how we can model these edges. There are again three different ways we'll try to cover. So the first type of edge is step edge. Okay. So step edge is like you will have like some continuous value in the pixel color and it suddenly it changes to like some other value, and again it remains the same. So this is kind of if you recall from the previous lecture, like we were talking about uniform distribution where we had the step function. So this looks exactly like a step function, and this is called a step edge. Some other edges could be not, they might not be this sharp. There might be some continuity there, and these are called ramp edges. And what's happening here is when we are changing levels between these colors, so again, you're going from this level to this level, right? Which is exactly the same as this scenario here. The only difference is you are not doing that abruptly as a step. You are doing that like in some continuous fashion. So it's increasing gradually. Okay, so this is called ramp edge. The other kind of edge is like roof edge, and this is slightly different from these two edges. In this case, like your pixel value is low, it's increasing, and then again, it's coming back to the original value. So it's increasing and coming down. So it's kind of forming a roof, and that is causing this edge. Okay, so these are three different models. Now, one of the question like which we should try to answer is, okay, all right, that's fine. Those are edges. The reasons we understood why they are forming. We try to understand different models, but why extracting these edges is important. We try to cover that briefly when we talk about it can reduce the memory consumption to save your images, but still preserve some information. But that was just one use. There are a lot of other different applications where edge detection can be useful. So you can use like maybe object recognition as a downstream task. So you can extract edges from the images and use that for recognition. Right? You can use it for like recovering some kind of geometry. So for example, like if you have an image and there is some occlusion, right? So if you just try to extrapolate edges, or you have some kind of prior knowledge, so you can try to recover those objects. So that could be one interesting application. And the reason is like, again, so these images are just showing you edges over here. I mean, you don't have any pixel values. You don't know what color we have, what kind of texture we have. It's just like edges, right? And still, as a human, we can say that this is a plane, this is a house, and this is maybe a mouth, tongue sticking out, a nose and an eye. Okay, so which means that edges are powerful and they can be used for like a lot of different applications in computer vision without even using like the color values. Okay, so now we talked about that motivation, which is good. Now let's have a very close look at the actual images and what does like having an edge really means. So this is an original input RGB image, and this is let's focus on this particular patch over here. So if we zoom in on this, it will look something like this, and you can see here that there are like multiple edges, and these are vertical edges. Right, this is the first, actually this is not even visible here, but this is an edge, and I think this is the surface normal is actually changing. And again, we have an edge here. This could be like illumination due to different lighting conditions, and again, this is different lighting condition, or the surface normal might be changing. It might be like both might be happening at the same time. Okay, so we have all these edges here. Now, again, we have an edge over here. This is again, the surface normal is changing, but again, the lighting condition is also different, which is causing like the pixel values to change. And this is like interesting. The surface normal is not changing at all. The illumination is also not changing. It's uniform. It's because of the texture which is there at this location, right? So that's why we have all these edges.